Hi, I'm Dennis, and I welcome you to a very short overview of data exchange. In this presentation, we'll see the data exchange workflow, what are the concepts the data exchange operates with, we'll understand how the data is organized, and in the end, based on all we discussed so far, we'll see where actually data exchange fits, when to use it and when to not. In some previous presentations, like during different Autodesk University classes, we talked about challenges in cross-application collaboration, and that the current workflow is mostly based on exchanging binary files. The main vision is to move away from the binary files and use the data layer, common to all applications, as the way to exchange data, be it between Autodesk or non-Autodesk applications. However, before diving deep into data exchange internals, let us quickly review the data exchange workflow from a user perspective. For now, the data exchange creation workflow is available only through ACC and Revit and works only with Revit 2023 files. However, as we will see further, this is just the very first step, and in the future, source app as well as the environment will be extended. The current implementation of the producer connector relies on Revit view. In other words, the producer connector will use a Revit view to know for which parts or components to share data. In this case, it is a subsection of the model, and the current implementation of the producer will automatically prepare for exchange the geometry and the properties of 107 objects included in this 3D view. Once the exchange is created, since it also contains the 3D view, it can be visualized within ACC or Forge Viewer. In case the source file is updated, here it is a Revit file, within ACC it will automatically update the exchange data. The difference between versions can be easily spotted within built-in ACC Compare tool. In this case, we see that a door was added and the wall was modified. But how about identifying the changed data? How to spot which properties of the wall changed? And we'll see later how, using the Data Exchange API, we can easily get just the data exchange between these two versions. To better understand how the data is organized within an Exchange container, let us look first at some concepts used by Data Exchange to describe and organize data. First concept is the collection. In context of ACC, a collection corresponds to the project, and consequently, all exchanges created in a certain ACC project will be part of the same collection. A space corresponds to an Exchange container, represents a logical group of assets, and consequently, all the data exposed through Data Exchange will be in the same space. An asset is the entity responsible for holding properties corresponding to a model part or group of model parts. Relationships represent the links between assets, and all these assets relationships are forming the data graph. Snapshot is responsible for keeping track of the state of the graph, and a snapshot revision is the pointer to a certain state of that graph. This was a very brief overlook, but let us look deeper into assets, relationship, and snapshots, as these are the most encountered entities when using Data Exchange API. First, and the most encountered, will be the concept of asset. As we already mentioned, the main scope of this asset is to store properties. Based on what type of information is stored, there are multiple specialized assets, group assets, design assets, instance assets, and so forth. Out of these, the most useful for now are the group assets, design assets, and instance assets, because these assets will contain data, the properties. The binary assets and geometry assets are also useful, but they are not directly accessible. They are accessible through Geometry Utility SDK that we will see later. In case of relationships, they are used to link assets, and there are two types of connection: reference relationship and containment relationship. All the assets and relationships form a graph, but with each version of the design, some assets will go away, others will be added, some of them will be modified, and so on. For this very reason, there is a need to keep track of the graph state and this is where the concept of snapshot comes into play. Each data exchange will have a single snapshot, which can be seen as a pointer to a data graph or to an entire graph. The states of the graph is referenced through snapshot revisions. I thought it might sound confusing. The approach allows not only to get all these assets and relationships that exist in a certain state of the graph, but also allows to easily get the difference between needed states of the graph. We'll see all this later. The most important thing here to keep in mind is that all mentioned entities, although different in purpose, they all share the very same structure. So they all will have ID needed for identification, type to describe what properties it is expected to have, as in case of different type of assets. Reversion ID needed to keep track of different versions of the same entity, attributes used to store system or application-specific properties, and here the most important are the components, because they are used to store properties using the schema-based structure. Then each specialized entity, like the relationship entity, will have some additional fields needed to fulfill their responsibilities. In this case, from asset and to asset fields, to show the connection and the direction of this connection. In case of assets and relationships, no entity is ever deleted. Therefore, they need an operation field to mark their status. It can be insert, modify, or remove, but the remove value doesn't mean that it is deleted. It just means that it's not part of the current state of the graph. Now that we are armed with all these concepts, let us look deeply into the Data Exchange REST API. The Data Exchange REST API is very simple, and to be able to use it efficiently, you have to know 4 calls. First, how to get the Exchange container to be able to access Exchange data, how to get assets and relationships to traverse the graph and get the needed data, and lastly, how to get revision snapshots to be able to get the data for specific version, or to be able to get the difference between needed versions. Let us go from the end and start with the snapshot revisions and diffs. As we mentioned before, a snapshot is a pointer to the data graph. Although it contains some information, like how many assets and relationships were marked as created, removed, or modified, we'll see later how to get the very same information in more useful contexts. It is important to remember that the version of the Exchange item in ACC environment is merely for reference. Unless we specify the version of the data graph we want to use for the data query, we will always access the latest version. As in this illustration, we see from the version that these stats corresponds to the version 3 of the Exchange item, created from the version 3 of the source Revit file. To be able to get the data from an early version, we must rely on snapshots revisions. The snapshot revision is very important as it opens the door to the data history. When illustrating the user workflow, we created a data exchange from a Revit view. Then we updated the Revit file, which subsequently triggered update of the data exchange. By retrieving the snapshot revision, we see that for the very first version, since it was created from scratch, we had a big number of created assets and relationships. For the second version, since it was an update, we notice a relatively smaller number. Now you can guess that when we will ask through Data Exchange API the diff between these 2 versions, we will get 15 assets and 11 relationships. And from their operation status, we will easily spot the ones that were inserted, modified, or marked as removed. The revision ID is the part we need when referencing the version for which we need to retrieve assets and relationships. Retrieving assets and relationships is done through separate endpoints with the same structure. In case no revision ID is specified, the call to these endpoints will just get the assets and relationships for the latest state. Both these calls support filters query parameter, where we can specify from revision and to revision keys. These powerful filters query parameter supports combinations. In case we specify only the to revision filtering parameter, we will receive the assets or relationships, depending on what endpoint we call, that corresponds to the given version. In other words, if we're interested in parameters of the wall as they were in version 1, then we just request the assets and specify to revision value corresponding to the first version. The same is valid for any other versions. However, in case we specify both from revision and to revision, we will be provided with a list of assets and relationships that changed between the specific versions. Let us quickly go through an example based on data exchange we created when we were reviewing the user workflow interface. To get all the assets and relationships as they were in version 1, we must specify the toRevision filter and give the revision ID corresponding to version 1. Among received assets, we notice the instance assets holding the value for the needed wall. We can notice right away a maybe unfamiliar way of how the data is structured within assets. But this schema-based structure determines consistently, and you can now notice right away the type and precision of the value. The schema-based approach helps making sense of the data for the consumer connector, avoiding confusion for interpretation. The same thing we can do for version 2 of the data exchange or any other versions. And we notice in the body of these two versions of the assets the operations fields. In case of V1, it is marked as insert because it was initialized, while in case of V2, we see it marked as modified, obviously because some properties in it changed. This can be seen as a way of finding the changed assets by searching the assets and relationships marked as modified, but there is a neater way for that. Note that these two versions of the same assets have the same ID, but their versions of ID is different. This is because they belong to different state of the graph, and their revision ID are actually the revision ID of the snapshot, and we can use that. When requesting the assets or relationships, if we use together from revision and to revision filter and pass the value of revision ID corresponding to V1 and V2 of the data exchange, we will get the assets or relationships that were modified, created, or marked as removed between these two versions. In other words, we'll get the change. When we were looking at the revisions, we noticed that for revision 2, we had stats mentioning that there are 5 newly created assets and 10 modified assets. The modified assets are the best candidate to identify the changed properties. Since we know that the individual properties of the parts are stored in instance asset type, to narrow our search, we just have to look for those asset types. The 5 newly created assets obviously are related to adding the new door as the 8 newly created relationships. There was created a pack of assets, among which design, instance, geometry, and so on, and the newly created relationships are used to place them within the graph. The main purpose of the relationship is to show the connected assets and the direction of this connection. This is done through from and to fields, while the type of the relationships, be it containment or reference, shows the nature of this connection. Using the example of this slide, if we're interested in getting all parts belonging to wall category, we will start with room component. Through containment relationships, we get the group asset and follow the reference relationship starting with that node. As you can see, the data exchange REST API is quite simple to use. The most important thing to keep in mind is that the data within the data exchange is organized as a graph and represents a collection of assets linked through relationships. The graph is changing with each version, but the state of the graph for each version is recorded and can be retrieved through use of snapshot revisions. One of the most important aspects to remember is that even if the graph is changing by removing assets and relationships, nothing is deleted. Those assets might not be part of the current state of the graph, but they're still part of the previous state. The API is very straightforward. Having the exchange item URN, get the exchange container ID. Having the exchange container ID, you can get assets and relationships for the latest versions. If you want previous versions or get the difference between versions, check the revisions and use their ID as a filter. The current focus is to fortify the API with more filtering options to be able to narrow down the asset based on ID, type, or even contain properties. Since the output result might look too overwhelming, the engineering team is working now on GraphQL layer to simplify the API usability. Also, the engineering team delivered Geometry Utility SDK, which allows you to download the geometry stored in Data Exchange and make it available as a step file. It is available now as a public beta, and it waits for your input. The Connector Kit SDK will also be available later as a beta. But to better explain its purpose, let us review the Data Exchange workflow so it can be clearer what will be the purpose of the Connector Kit SDK. In general, when illustrating the Data Exchange service functionality to users, we use Revit to invent a workflow. But that workflow is merely an example of a generic workflow where we have a source application which wants to exchange data with some target application. These two applications may be from totally different industries and subsequently speak totally different languages. For one application, a wall is an assembly of studs, isolation, finishing, and so on. For another application, it is just a surface, a shape, or something else. Storing data in the cloud is not a big deal, for example, storing a number like 42 in the cloud. For one application, this might be the meaning of the universe, while for another application, this is the width or the floor. So, even if the source application is storing data in the cloud, it must be meaningful, while the target application must be able to usefully interpret it. We already seen how this is achieved through schemas. And in this illustration, the purpose of the connectors between application and the cloud storage is to meaningfully store and retrieve data. The producer connector is responsible for getting the data from the source application in a granular form, while subsequent changes will not require full re-upload of the data, but just of the changed data. The consumer connector is responsible for accessing the data and interpreting it for the target application. Since the data is granular, it can get only the needed data instead of downloading the whole set, or it allows retrieving only the data that exchange from the last access. This is exactly what we have seen so far through use of the REST API. So you can see the workflow have the following pattern. The producer connector gets the data from the source app and stores it to the cloud, and the consumer connector gets only the needed data from the cloud and interprets it for the target application. These two connectors, the producer and consumer connector, are the two programmable points that will be available to developers through Connector Kit. The Connector Kit will contain tools needed to meaningfully store and retrieve data, as well as defining through concept of contracts what data is exchanged. Moreover, the Geometry Utility SDK, which will be part of the Connector Kit SDK, is available as a public beta right now and allows you to get the geometric asset as a consumable step file. Thus, right now having the described data exchange REST API along with the Geometry Utility SDK, you already have all necessary tools to access in raw form the data and the geometry from the exchange and start build your own workflows around it. I hope this presentation helped you understand how Data Exchange works and maybe even gave you some ideas on integrations, but to benefit from it, you must keep in mind not only the benefits, but also keep in mind its weaknesses. The Data Exchange service is best suited for workflows where there is a need to share a subset of model instead of the entire model. Since it has granular access to data, you can retrieve only the data you need, and it's very easy to get the data for the parts that suffer changes. On the other hand, since it is tailored towards subset data sharing, obviously sharing the entire huge model through it might not be optimal, and other services like model derivative might be the better solution. Last but not the least, the data is organized to better support the service workflow and might be difficult to work due to how it is structured. However, data is data, and no matter in what format it is, the current and potential benefits of its structure outweighs the small inconvenience which can be easily mitigated. And this is what the engineering team is doing right now, working on the GraphQL implementation that will ease the use of the API. That's it. Don't forget, documentation is your friend, and on the documentation page we have a lot of information, tutorials, and of course the API references. Here you can find the geometry utility SDK, as I mentioned. It is in beta, and looking forward for your feedback.